Hello there! Let's get started talking about the properties of water and how water's properties sustain life. Let's begin by picking up with the polarity of water. As we touched on when we first discussed polarity, for something to be considered polar, it must meet all three of these criteria, right? Now, in reference to water specifically, we already touched on the first two criteria in decent detail when we went over the concept of polarity. What I want to focus in more on with you right now is this last criterion. Okay, now I already told you that the ends of water or of a water molecule have different charges, but how could you have determined this on your own if you were asked? Let's look at that. To figure this out, we need to first address two key questions. Which element is more electronegative, hydrogen or oxygen? And what does electronegativity actually mean? So looking at our periodic table with electronegativities, we see that oxygen is more electronegative, right? 3.5 versus 2.1. Now, what does electronegative actually mean? Electronegativity is an atom's ability to attract electrons towards itself. So looking at the periodic table, we see oxygen has 8 protons, while hydrogen only has 1 proton. Remember, protons are positively charged. So between these two hydrogens, and the one oxygen that goes into making up the water molecule, the oxygen will pull the hydrogen's electrons towards itself because it's more positive, it's more electronegative. Now, if you are losing a negative charge, that means you are becoming more positive, right? So since oxygen is moving hydrogen's electron towards itself, or closer to itself, that means that the hydrogens have become slightly more positive because of this, while oxygen has become slightly more negative as it's gaining those electrons. Does that make sense? So circling back, does one end of a water molecule have a different charge than the other end? Yes, right? Where the oxygen in the water molecule has a partial negative charge, and the hydrogens have a partial positive charge, each one of them partially positive. But who cares? How does water's polarity influence its ability to interact with other molecules? Let's think back to magnets. If we have a magnet with positive and negative ends, the positive end will be attracted to the negative end of the other magnet, right? Same for polar molecules. Water can form bonds with other polar molecules, like other water molecules, or even molecules such as ammonia. And it has a high propensity or a high likelihood, therefore, to form hydrogen bonds with other molecules specifically. The reason why understanding water's polarity is so important is because the likelihood of molecules forming bonds and or being able to dissolve in water is based on the polarity of the molecule and the resulting hydrogen bonds that form between water and that molecule. Water is a versatile solvent due to its polarity, which allows it to form hydrogen bonds very, very easily. Now, when talking about a molecule's interaction with water, we refer to them as either hydrophobic or hydrophilic. A hydrophilic substance is one that binds readily with water because it's a polar molecule, just like water. In contrast, a hydrophobic substance is one that does not or cannot interact with water. Hydro, right, meaning water, and phobic, meaning fear, right? Think about phobias. For example, if you have ever dumped oil in water, you've seen how hydrophobic substances like oil can be. Oil molecules are hydrophobic because they are relatively nonpolar. They have relatively nonpolar bonds. They have no partial nor no negative charges on either side. So time for our first check-in within this lesson. Keep in mind, this is check-in number 16. So make sure that you're looking at number 16 when you're filling in your responses, okay? Check-in number 16 is water polar or nonpolar? And is water more likely to interact with polar molecules or nonpolar molecules? Now, what's so incredible about this, about what we've been talking about, is that because of this very simple interaction that you see, this ability of oxygen and hydrogen to come together and form water, and then water's ability to form hydrogen bonds so easily, because of this, life is able to exist. A water molecule's polar nature is what allows it to form hydrogen bonds so easily. And those hydrogen bonds help sustain life. But how? Well, because of hydrogen bonds, water sticks to things very easily. It helps maintain homeostasis, such as regulating temperatures. It is less dense as a solid as opposed to a liquid. And finally, it is an excellent solvent, meaning it dissolves things very well.